Super excited to be here surrounded by such a nice crowd of Web3 maximalists. Let's see, yeah. So the nice thing about being surrounded by so many Web3 maximalists, you are, guys, people that have this strong hope for decentralized systems to preserve freedom or to bring back freedom for the individual, for humanity. I mean, the Web3 promise is unstoppable code. That's amazing. But I'm here today to talk about one hidden layer that damages that unstoppability and that prevents Web3 from fulfilling its promise. I don't know if this is working. It is not. OK. Yeah, perfect now. So what I'm talking is blockchain oracles. This is kind of the elephant in the room. Today, I have a mission, which is to pull back the curtain on blockchain oracles before somebody else pulls the rug. I'm Adán Sánchez de Pedro, the founder of With Oracle and the Witness Foundation, and this is the oracles secure the data, but who secures the oracle? So let me first take a step back. No, sorry. Who knows what's a blockchain oracle? Yeah, I see a lot of hands. So this was kind of a hot topic a lot of time ago, but there's a lot of people that have joined the space recently, and they haven't had the opportunity to learn about blockchain oracles, or maybe they didn't care or dared to ask, which is kind of my main point here. This is something that remains overlooked many times. So I want to explain it very simple, but with a twist, in a different way, so that even some of you who raised your hands may reconsider what you know about oracles. Your typical explanation of oracles would start saying that the real world is full of randomness, that there are random behavior. You know, it's the beauty of life, right? But all of this is what technical people we call indeterminism. On the contrary, blockchains, because you need to run your code on multiple computers, on multiple nodes, you want them to behave the same. You want the code to produce the same result in all of them. That's what we call consensus. So we want blockchains to be deterministic. This concept of determinism, it's quite technical and rather philosophical, but it may sound fancy, but it's something as simple as expecting the same result when you apply the same process on the same raw material. So you take some fruit, you throw it into your blender, you let it run for a minute or two, and you get fresh smoothie, right? If you take your iPhone and you put it inside your blender and let it run for a minute, or you better not do that, you're not getting fresh smoothie, right? So my point here is that in deterministic systems, the outcome is largely affected by the input. This leads to this effect, this principle of garbage in, garbage out, which applied to blockchains and smart contracts means that it doesn't really matter how good your code is. It doesn't. Maybe you are the best Solidity or Rust developer, and if you are, please come talk to me. But your contract will only execute correctly if it operates on correct data. So you can see this big gap between the real world and the blockchain. And when very clever engineers were into creating Ethereum and Polkadot and all of these smart contract systems, they realized this and they created big firewalls there. They didn't want inconsistent data to pollute the chain state. They didn't want this indeterminism to creep into your smart contracts and eventually even jeopardize consensus. So that led to a lot of blockchain isolation. Let's say blockchains are quite isolated. They cannot have a big capability of accessing data from the outside. This clearly limits the number of use cases that we can build on top, but also it creates some perception in the public that Web3 and crypto is only for self-referential, speculative use cases and not so much for real transformative impact on society. This is what we call the oracle problem. Basically, how do you build determinism from indeterminism, or how do you bridge the gap between the blockchain and the real world, ideally in a secure way? So you solve that with oracles, okay? Pretty much like the oracles in the ancient times would be like the link or the connection between the human and the divine. Blockchain oracles are any kind of system or entity that connects the on-chain to the off-chain. So I promised the twist. Here's the twist. Ladies and gentlemen, oracles are not what they seem. I've been building oracles for the last 8 years, and if I had to give you one takeaway or kind of summarize my learnings in a single slide, the next one would be it. You want to see it? So this is what most people think that oracle look like. So you have a smart contract. It uses an oracle to fetch data from the outside. That's about right from a technical standpoint, but at the same time, it's completely wrong, because you're missing the human dimension of this. What you actually have is builders, is teams, is people that use the oracle to have access to peace of mind. When you're looking for an oracle, you're looking for somebody else to take care of data, to take care of the secured input of data, and make sure that data won't go wrong, and you want somebody else to take the blame. You want, as a builder, you just want to feel safe building, moving forward, creating new things. So that's a key here. How do you achieve that peace of mind? That's what tells one oracle system apart to other, how they approach creating that peace of mind, that security, that safety. So here's the catch. There's no formal definition of what an oracle is other than, yeah, system that pushes data into your smart contract, okay. But there are so many things under the oracle name that are nothing like each other, that they have very, very different nature. Just like a Chihuahua and a Doberman, they're both dogs. They have 4 legs, 1 tail, they bark, they poop everywhere. But would you trust them both to guard your house? Probably not. So the first approach that we have been seeing to oracles, the first category out of 3 that I'm trying to explain here, is what I call the noracle. Is the situation in which data is introduced centrally by either the creator or the deployer of the smart contract, or some kind of trusted third party, normally some reputable entity, some company, whatever. This pattern can be quite effective in practice, as long as that single point of failure, that single trusted entity will continue operating. And we know for certain that they can at any time, because of technical reasons, economic reasons, regulatory reasons, whatever. When we adopt this pattern, we are basically defeating the purpose of using a blockchain in the first place. All the nice properties that blockchain give us about censorship resistance, about resilience, about trustlessness, we are not getting it if we go this way. Instead, what we are inheriting is the vulnerabilities that this single trusted party may have. So going back to the title of the presentation here, who's securing the oracle? In this case, it's going to be a trusted party. So you're basically handing over the keys to your safe box to this entity. And some famous instances of this pattern could be Oraclize and other early Oracle projects. Also, the Chainlink VRF, for example, that uses a single coordinator model that can stop feeding randomness at any time. And most recently, pretty much anything under the real-world assets category. Then you have multi-party oracles, which is quite better approach in as much it creates some kind of trust mitigation into the system, and also some check and balances so that garbage won't make it to your contract that easily. Some relevant examples of these are early versions of MakerDAO, Gnosis, Augur, Curve, and many other protocols that we use today. In addition to pretty much anything in the Chainlink toolkit, where there's a closed set of node operators that are whitelisted and KYC'd by the Chainlink company. And those interact through an aggregator contract or through their rather opaque off-chain reporting system. So in general, every time that you see like some kind of multisig or some kind of aggregator contract in place, it would fall into this category, which means that everything using Chainlink, of course, sorry, bad news, they fall into this category. When we use these type of oracles, we are not trusting a single entity, but rather a collective, kind of a committee, and the integrity of the data still comes and it still depends on those behaving properly. This model generally doesn't offer any real verifiability and still relies on named entities, on trust and reputation at multiple levels. And if anything goes wrong, any remedy or any enforcement will not happen on-chain, but rather on the phone, because there's no crypto economic involved, there's no such thing as slashing. And finally, you have like the proper decentralized oracles. In this category, I only put the ones that truly live up to the security properties of the blockchains they serve. When you post an oracle query to a completely decentralized oracle, you can rest assured that you will get a response back, and that response will be a true representation of the data that you wanted. And it hasn't been manipulated or tampered with in any form by any of the participants in the oracle, anyone involved in the process of sourcing the data. This is also the only category of oracles that pass what they call the walkaway test. What happens tomorrow if the founders, if the team behind your oracle disappears completely? Will your oracle still exist? Will it still work? Will it still be secure? If that's the case, that's what we are talking here. If it's not, if your oracle needs some babysitting, what the fuck are we doing? So the nice thing about decentralized oracles is that when you go and try to answer the question about who's securing the oracle, it doesn't really matter. What really matters is how to do it, not the who, but how to do it, because you have multiple mechanisms in place that create that trust mitigation, that leverage incentive design and crypto economics, generally staking and so on, and that create real-time accountability so that you can build a system that provides provable data and security without having to trust any of the parties involved. This is, let's say, Oracle level peace of mind. That's the ultimate level of peace of mind. There are a number of projects that are building in this category. There's a few that I can confidently say that are sufficiently decentralized. None is perfect. There are always trade-offs and compromises, but some of them are like Teller, Sita, and of course, the WIT Oracle. Which I think is the most sophisticated, elegant, and complete implementation of a decentralized oracle as of today. And it's because the WIT Oracle it didn't came out of nowhere. The WIT Oracle or WITnet, we can really say that it stands on the shoulder of giants. Here kind of literally, but also because it's rooted on classic literature on game theory, on incentive design, and on focal points, and also on research by a lot of builders from the last decade who have pioneered and paved the way for truly decentralized systems. All of this research led to the publication in 2017 of the WITnet white paper. It's a rather technical and dense paper that describes how to implement a truly decentralized Oracle network based on the concept of crowd attestation. The way crowd attestation works is that you have a broad network of validator nodes that are independently run. And when you have an Oracle query, you post that to the network, and that will get assigned secretly and randomly to a subset of those. They will commit, they will execute the query itself, they will fetch the data, they will commit the data through a cryptographic commitment scheme, and eventually reveal what was inside the commitment. Once they have all revealed, we can tally the result, we can aggregate the results, and here's the nice thing. Only those validators that provided data points that coincide or are close enough to the final result, they will get a reward. Otherwise, they get immediately slashed. This is what they call a shelling point game. The beauty of this design is that this trust mitigation exists at multiple levels. You have redundancy at the data source layer, where you can aggregate from multiple data sources, remove any outliers, and so on. But then the same aggregation filtering happens at the reporter level, with the different nodes that will be independently producing those commitments and reveals. And what you get at the end is a single data point that cannot be tampered with and that cannot be manipulated by any of the parties involved here. All of these, in the case of the with Oracle, is made possible by a layer 1 chain. It's a really bare bones one that rather resembles Bitcoin in its kind of minimalistic design, but the transaction types that exist in the protocol are very tailored to the use case of the Oracle. You have like different transaction types for the commitment, the reveals, and the tallies. And this Oracle chain, let's say, is kind of side-chained to more than 50 different EVMs, and that's what enables the message passing of the queries and the results back and forth between the Oracle chain and the EVMs. We have also explored support for Polkadot. We have drafted, have a prototype for a substrate palette, but right now what we are looking at is the direct integration with Polka VM. And all of this is incentivized by the WheAT coin. Again, it's kind of similar to Bitcoin, where it's UTXO-based, which is something very interesting for the Oracle use case. And basically, anyone can spin up their own with Oracle node and start earning some WheAT right away through staking. The nice thing about this kind of staking is that what I call useful staking, because in addition to be earning some yield, 20% APY right now. By running a validator, you are contributing to the security of the chain, but also to the security of the Oracle. You are contributing to the security of the protocols that are using the with Oracle. And eventually, you are contributing to the general increase in security of the Web3 ecosystem as a whole. So you are part of a kind of public good. So at this point, what's the point of creating all these kind of systems? What are we afraid of? What are the real threats? Of course, I'm not claiming that the decentralized approach is better just because I have a fetish for decentralization, which I have obviously, but that's not the only reason. Generally, I would try to run away from discussing security properties in a abstract way. I prefer to discuss specific attack vectors. So the reality here is that shit happens. Shit has happened in the past, and shit will continue happening. And if I had to give a talk on protocols that have lost some users' money because of Oracle attacks, or because they were not using an Oracle, I would not only need another 20 minutes slot, but rather take over the 3 days agenda. You don't want that. So the most immediate impact of Oracle attacks is obviously monetary loss, but also the reputational damage. The users lose their money, but the teams also lose their credibility. But that's not where the story ends, because when we look at Web3, we have this beautiful layering and interconnection between protocols and dApps, what we call the monoligos, right? So when a protocol pays little attention to their Oracle policy, they're not only shooting themselves in the foot, they are creating systemic risk. We as builders, we need to be very aware of this and act responsibly, because already in the past we have seen that the hacks that have happened have spread that monetary loss and reputational damage like wildfire across the ecosystem, and that can really create a bad perception of Web3 and crypto and can drag the adoption. When I started working full-time in crypto like 10, 11 years ago, I remember there was no Ethereum, there was no Polkadot, but there was something bigger. There was the vision that Web3 would serve as the foundation, as infrastructure for human freedom. And during these years, of course, we have had a great time. We have earned some money, lost some money to ICOs, NFTs, meme coins, DeFi, whatever. But all of that fun maybe have distracted us from one key fact, which is that we cannot look away from infrastructure. We cannot afford to. I'm talking oracles, but I'm talking also JSON RPC providers, validators, hardware wallets, collators, sequencers, all this kind of infrastructure that we often overlook and that we give for granted. And I actually get it, because oracles and infrastructure, they don't make the headlines. You want to become a key opinion leader on crypto Twitter discussing data integrity. And you could argue that oracles are not degen enough. But oracles are a key piece of blockchain infrastructure. And if the infrastructure breaks, everything breaks. Your dApp, your DAO, your stablecoin, your lending protocol, everything collapses like a house of cards. Again, we cannot afford to look away, because sometimes it's the boring stuff that makes the magic work, and it's the unsexy that matters most. But it's not all bad news. We are starting to see more and more projects care about all of this, care about infrastructure. There's a renewed interest in infrastructure, in oracles, and on all the points that I made here. We are seeing more projects migrating towards decentralized oracles. We have, for example, great success case with Pull Together, who moves from Chainlink to the WIT Oracle. So there's hope. There's still a brilliant future ahead for Web3. We are in time to build the Web3 we were promised, but only if we care and only if we dare to also build and use, of course, the oracles that it deserves. From the WIT Oracle and the Witness Foundation, we have always been committed to this vision of technology that set us free. We are really proud of being leading in the forefront of this revolution, and our hope is that more organizations, more projects, and more builders join us in this journey to build together a safer and brighter future for Web3. Thank you so much.